All right, we're going to be multiplying radicals, adding radicals, and simplifying right afterwards. So when you multiply radicals, you're going to say the outside times the outside, and then the inside times the inside. So I'm going to have a radical down here, but I'm going to have the outside times the outside. That would be 2 times 4 is 8 on the outside. And then on the inside, I'll have 3 times 2, which is 6. That's all you got to do. 6 is already simplified enough, and that is our final answer. The next one we've got outside times outside. That's 2 times 3. That would be 6. And then inside times inside would be 6 times 3. That's 18. And 18 is not in simplest form. There's a perfect square that goes into 18. That would be 9. 9 times 2. So I would rewrite that as 6 times the square root of 9 times the square root of 2. And the square root of 9 is 3. And 6 times 3 is 18. Square root of 2 is my final answer right there. Next one, same kind of ordeal. Outside times outside. There's a 1 hiding right there. Don't forget that. So 6 times 1 is just 6. And then 3 times 3 on the inside would be 9. The square root of 9 is 3. So final answer there is 18. Outside times outside. 5 times 2 is 10. Inside times inside, 2 times 6 is 12. There is a perfect square that goes into 12, and that is 4. That'd be 4 times 3. You could rewrite that as 10 times square root of 4 square root of 3. And the square root of 4 is 2. So 10 times 2 would be 20 square root of 3. Final answer. Same kind of ordeal if you have 3 of them that you're multiplying. So you're just going to take all the outsides and multiply, and then all the insides and multiply. So don't forget there's a 1 hiding right there. So I got 3 times 1 times 2. 3 times 1 is 3. Times 2 is 6. And then on the inside, I'll have 2 times 3 is 6. Times 6 is 36. Well, what's the square root of 36? 6. 6 times 6 is 36. On the right side, same kind of ordeal. Don't forget there's a 1 right there. So 4 times 1 times 3. 4 times 1 is 4. Times 3 is 12. And then I've got 3 times 2 is 6. Times 5 is 30. And I don't think there's a perfect square that goes into 30. So we're going to leave it just like that. 12 square root of 30. If I'm adding or subtracting radicals, I need to look for like terms. Each of these are like terms. Square root of 2's can be added with other square root of 2's. Square root of 3's can be added or subtracted with other square root of 3's. So 4 square root of 2 plus 3 square root of 2 would just be 7 square root of 2. 7 square root of 3 minus 2 square root of 3. I can combine these because they're both square root of 3's. This would be 5 square root of 3. 7 minus 2 is 5 square root of 3. 5 square root of 6 plus 2 square root of 6, that would be 7 square root of 6. And then down here, you could simplify first. You could say square root of 4 is 2 and kind of go from there. But we could say 3 square root of 4 minus 1 square root of 4 is 2 square root of 4. And we know that square root of 4 is 2. So 2 times 2, final answer is 4. These, however, I'm going to need to break one of them down in order to combine. So 3 square root of 2 is fine the way it is, but I need to rewrite the square root of 8 over here. I can't combine square root of 2's with square root of 8's unless I can simplify that square root of 8 there. So I know that the perfect square that goes into 8 is 4 times 2. That would be 3 square root of 2 plus 5 square root of 4 is 2 times square root of 2. And that would be 3 square root of 2 plus 10 square root of 2. So final answer would be 13 square root of 2. If I'm looking at, let's just do the top right while we're here. So I can't combine square root of 12's with square root of 3's, but I know that there's a perfect square that goes into 12. That perfect square is 4 times 3, so I can rewrite 12 as 4 times 3. And then separate them. That's square root of 4 square root of 3. That's 2. Square root of 4 is equal to 2. So that outside 2 times that 2 I just got would be 4 square root of 3. And we can't forget to bring this down. So 4 square root of 3 minus 5 square root of 3. That's going to be negative because that 5 is larger than that 4. I think it's going to be negative 1 square root of 3. You don't have to write that 1 there. You could just write negative square root of 3. So either that or that would be a correct answer. If I am simplifying, I can't have a fraction under the radical. So the first step is to see if you can rewrite it like this. So square root of 9 over square root of 25. And this one's really convenient because they're both perfect squares. Like square root of 9 is just 3, and square root of 25 is 5. So square root of 9 over 25 is equal to 3/5. And you could do something similar with this one. The one on the right side, top right, when you separate it, square root of 3 over square root of 16, you can't really do anything with that square root of 3, but I know what the square root of 16 is. So that could be written as square root of 3 over 4 as your final answer. And I mean, there's a couple ways to go about this bottom right one. The easiest thing for me is to recognize that, well, 10 is not a perfect square, 20 is not a perfect square, but I know that 10 over 20 is equal to 1/2. So the square root of 10 over 20 is equal to the square root of 1/2. Not 1/2, but the square root of 1/2. If I'm finding the perimeter of a rectangle like this, then I need to add up all the sides. You just need to recognize that, on a rectangle, opposite sides are congruent. So that's 5 minus square root of 2, and this would be 3 plus the square root of 2. And perimeter, you would just add up all the sides. So I'd have that plus that plus that plus that. So combining my like terms, I got 5 plus 3 plus 5 plus 3. That would be 16. And I've got negative 1 square root of 2, negative 2 square root of 2, and then I've got positive square root of 2, positive square root of 2. I think my perimeter is just going to be 16. Just combine all your like terms. You can punch that in your calculator. If I want to find the area of a rectangle, I know that area is equal to length times width, or base times height. The length we could call square root of 6, and the width we'll call 2 plus square root of 2. And if I see something like this, hopefully I can use my calculator and I can just multiply it. If I don't have a calculator, then I need to distribute. So I'm going to say square root of 2 times, or square root of 6 times 2 is 2 square root of 6 plus square root of 6 times square root of, that's square root of 12, I think, inside times inside. And then I would need to simplify this over here on the right side. That would be, after some simplifying, 2 square root of 3. You change 12 into 4 times 3. And then I think that that's going to be your final answer.